behind. So I want to remind you that lessons are videoed. So we're going to go through some stuff today. We're going to try to go back and pick up what we missed. But you're not going to have as much time with it as the other class was because they had a whole class period. So if you need more time with it, you watch yesterday's video. But we will spend some time on it today. What I want to do first, though, is have you turn, get your note sheets out. And I want you to turn to the back of page 58, to section 3, where it says evaluate by hand. We have not done this yet, right? We're on our new note sheets. We're on the back of page 58.
Oh, back of that.
We have not done section 3, part 3, right, where it says evaluate by hand. Okay, that's where we're going to start, and then we're going to go back and fill in the other stuff as we have time, but we're going to start with number 3, evaluate by hand. Now, this notation you may have never seen before. That is just another way of writing 7C3 or C73. These all mean exactly the same thing. So if I didn't have the part by hand in there, you could just type this in on your calculator, right? Let's do that real quick, make sure everybody can. You need to be able to do that, obviously, to get answers. So type in 7C3 on your calculator and tell me what you get. 35. So we know the answer is supposed to be 35. Now, how did Mrs. Ford do this when she was your age and didn't have a calculator? We did it by hand. Now, how did it work by hand? It's real easy. There's a formula for combinations. Here's how it works. This right here, this, however you're writing it, is 7 factorial on the top. Now, I think you know where I got the 7, right? It's right there. And I'm going to divide that by 4 factorial, 3 factorial. Now, where did those come from? Well, I subtract these and then put that in there. So 7 minus 3 is 4, and then the 3. We'll do a couple more, but that's the setup. Now, it says evaluate by hand. Well, shooty tooty. I really don't want to do all this multiplication. You don't have to do all the multiplication. What does 7 factorial mean? 7 times 6 times 5 times 4 times 3 times 2 times 1, right? What does 4 factorial mean? 4 times 3 times 2 times 1? And that's 3 times 2 times 1? Oh, I know it's a lot of writing, but this is easy now because what's going to happen? You're going to be able to cancel. In fact, the 4, 3, 2, 1s are gone. And what's 3 times 2? So that will cancel with the 6. And all you have left is what? 7 times 5, which is 35. HC3 by hand. Okay, well, first of all, what's the formula? What's the setup going to be for HC3? What, Maya?
I was just looking at this 198 and seeing how you think of it.
Well, just time out. Right now we're on HC3. We're on B. We're doing B. Okay, so what would the formula be for HC3? Remember, this is the formula. So what's going to be on top? 8 factorial. And what's going to go on the bottom? 5 factorial, 3 factorial. Now we'll write it all out. 8, 7, 6, 5, 4, 3, 2, 1 on top. And what's on the bottom? 5, 4, 3, 2, 1, and 3, 2, 1. what do once you get it all written down? Start canceling. So the 5, 4, 3, 2, 1, you can just get rid of all that. You can cancel in any order you want. I like to do it in clumps if possible. 3 times 2 times 1 is 6. What's the answer? 56. This is not so bad, is it?
Next problem.
Hey, the next one's easy.
Is it always gonna end up at the first two numbers? Oh wait, no.
Okay, next we have 100. It's written this way, but don't let the way it's written confuse you. This means 100C98, right? Remember, this notation, this kind of, it's really kind of vectorish notation, is just a different way of writing the combination. So what would our formula say here? 100 factorial over 2 factorial 98 factorial. Now, I know Maya's giving me the evil eye back there because she's thinking 100 factorial, you gotta be kidding, Mrs. Ford. But stop and think about this for a minute. When we do 100 factorial, it's 100 times 99 times 98, 97, right? Now, I'm not going to write all that out because in the bottom, there's going to be a 98 factorial. Now, there's also a 2, but there's a 98 factorial. What's 98 factorial? 98, 97,
Oh, I won't cancel.
You don't have to write it all out because everything from the 98 on is just going to cancel. So all of this is gone. You don't have to write it all out. Does that make sense to you? That because you have that 98 in the bottom, all that's going to cancel. Now, you got a 2 and 199, so maybe we take 2 into 150 times. So the only arithmetic we have to do is 99 times 50. $49.50 is your answer. Feel free to not write it all out. If you can see stuff's going to cancel, then just cancel it. You don't have to write every single number on the top and the bottom and then cancel them out. Okay, here we go. One more. 11C6. Abby, what's the formula? 11C6.
11 factorial over. I don't understand why there's the 2.
Somebody tell her where the 2 came from in this problem. Where the 2 come from?
Oh, okay. Over 5 factorial. 6 factorial.
Yep. Now, 11, 10, 9, 8, 7, 6, ... I'm not going to write all that out because in the bottom, don't I have a 6, ... down here in the bottom? All that's gone. From the 6 on is gone. Now, I still have the 5, 4, 3, 2, 1 I got to deal with. But everything from the 6 on is going to cancel out. Maya.
But if the 5, 4, 3, 2, 1 is included in the 6 and below, then why do you
Because you have a 5 factorial, which is 5, 4, 3, 2, 1.
separate second?
Yes. Yes. Now, there's only one thing in the top, so there's only one set of numbers in the top, but the bottom's always going to have 2 sets of numbers. Now, anything here cancel? I see a 4 and a 2. I can cancel out the 8. 3 goes into 9 3 times. 5 goes into 10 2 times. So I have a little more arithmetic here. What's left? 11 times 2 times 3 times 7. So my answer will be 22 times 21, 462. So there's a little bit of arithmetic that's involved here, but it's not as bad as you think. Javon?
What is the 8?
That 4 times the 2 cancels the 8. Now, you can, that's how I chose to cancel. You can cancel any way you want. Just get rid of everything in the bottom. Oops, there's one more, sorry. 10C7. What's the formula, Will Alick, for 10C7?
It's gonna be 10 factorial over 3 factorial 7.
Perfect. Now think about this as you're writing it out. And I don't care if you want to write it all out, every single number, go ahead. But on the top, you're going to have 10 times 9 times 8 times 7 times 6 and so on. Isn't that what you're going to have on the top? What's going to happen on the bottom? Well, you're going to have your 3 times 2 times 1. But what's this going to be? 7 times 6 and so on. What's going to happen? Everything from the 7 on is going to cancel. What do you want to do with what's left? 3 goes into 9 3 times. 2 goes in 4 times. So we have 10 times 3 times 4. The answer is 120. Amaya.
Did you just write 10, 9, 8 over 51?
Absolutely. You're thinking ahead. Perfect. All right. Now we're going to look at 9.3. We're going to look at a few of these probability problems, and then we're going to go back and do a little recap from before. So, oh yeah, there's a lot here. Okay, so let's see what's going on. Maggie has a bag of M&Ms, as does Elizabeth. Each girl counted her M&Ms and has discovered the following proportions of each color of candy in her bag. See the chart. Okay, so what this means is that for Maggie, let's look at Maggie's table. She has 30%, 0.3, 30% of her M&Ms are green, 20% are yellow, and so on down the line. Do you understand what's going on in the table? Does that make sense? Okay. Now, I'm going to reach into Elizabeth's bag, so I'm going to look at Elizabeth's table now, and I'm going to grab one piece of candy. What's the probability that it will be green? 20%. The answer is 20%. Why is the answer 20%? Because in Elizabeth's bag, 20% of the M&Ms are green. So the probability of me picking a green one is 20%. Now be careful with the next one. Now I'm going to Maggie's bag. I'm picking one piece of candy. What's the probability that it won't be yellow? 80%. Now you can do that 2 different ways. How did you think about it? Only 20% are yellow, so that means 80% are not. What else could you do? Add them all up except yellow. She says if it's not yellow, it's one of the other colors, so I'll just add all those up and that'll be my answer. Either way, it's 80%. If a candy is chosen from each bag, what is the probability that they will both be red?
25%.
What's the probability it'll be red coming out of Maggie's bag? 20%. What's the probability it'll be red coming out of Elizabeth's bag? 30%. Now we have to decide what we are going to do with these two numbers. And I'm about to say something that is really important. I like to think everything I say is important, but this is really important. when you are doing two things at the same time, it's a multiplication problem. So if you are picking a red and a red at the same time, it's a multiplication. I need to pick a red one out of Maggie and a red one out of Elizabeth. When I use the word and, it is a multiplication. So the answer to the question is actually just 6%, 0.06.
I understand you multiply the day. Would that be 60 if they're both?
Now it's 0.2 times 0.3. Remember, when you multiply decimals, you have to have in your answer the same number of decimal places as you have total in the problem. Remember that rule? D, if a candy is chosen from each bag, what's the probability that neither will be brown? Okay, so look at the first bag. What's the probability that you won't get a brown one from the first bag? 0.8? Would everybody agree with that? Not brown from Maggie. Okay, what's not brown from Elizabeth? 0.9. What do I do with those two numbers? Multiply them, because I want not brown and not brown. So that would be 0.72. And means multiply. E, if a candy is chosen from each bag, what's the probability that the first one will be green and the second one will be blue? Okay, so I need to get a green one out of Maggie. What will be my probability I'll get a green one from Maggie? 0.3. What's my probability I'll get a blue one from Elizabeth?
0.2.
A blue one from Elizabeth, yeah, 0.2. What do I do with those two numbers? I want a green one and a blue one. I multiply, so 0.06. So far, are you doing okay? Thinking this isn't too bad. What am I ready for? F. If a candy is chosen from each bag, what is the probability that one will be blue and one will be green? Uh-oh, this is tricky. I just need to end up with a blue one and a green one, right? So I could get blue and green, or I could get what?
Green and blue.
Green and blue. Now see, I didn't worry about that in the last problem, because in the last problem they said the first one will be this color and the second one will be this color. Now they're just telling me I want both colors. So I have to do two problems. Let's do this problem first. First blue, second green. Are you good with 0.1 times 0.2? For Maggie being blue and Elizabeth being green? So that's 0.02. Now what about green and blue? 0.3 and 0.2. Are you good with 0.06 for green from Maggie and blue from Elizabeth? Now, this is an or situation. It could be this, or it could be this. So what is the total probability? You have two separate probabilities. What's the total probability? What's the word total mean? What do we do when we total things? We add them. So the answer is 0.08. Important thing I've said today. When it's an and, we multiply. When it's an or, we add. Maya?
Does it matter if you write it as a percent or just?
Nope, does not matter, you can say 8%. G, if a candy is chosen from each bag, what's the probability that neither will be red? Okay, that's an easy one, don't make it hard. I don't want red. So what's the probability I won't get red from the first bag? 0.8. And the probability I won't get red from the second bag? Answer to the question is 0.56. Now, we're only going to do 2 of these problems, and then we're going to go back and do a quick recap, okay? Now, things have changed. We've shifted gears. Letter A. How many 5-card hands are possible from a standard deck? Is everybody in here familiar with a deck of cards?
Yes, ma'am.
So you all know there's 52 cards in the deck, right?
Yeah.
Okay. So here's the question. How many different 5-card hands are possible? Well, how many cards are there? I love you, Tyler Decker. 52C5. 52C5. Now, let's talk about that for a second. Why 52? Because there's 52 cards to pick from. This is your pile. You have 52 cards to pick from. Why 5? 5-card hand. Why C and not P? The order doesn't matter. The order doesn't matter. For normal card games, that doesn't matter. I'm sure there are some card games where it does, but we're not going technical weird stuff. Just normal, 5-card hand, the order doesn't matter. Like if you're playing money or something. Now, that is the answer to the question. Can somebody do this for me? What is this number? It's going to be large. One more time.
2,598,960.
That's just
960. So there are that many possible hands from a standard deck. Okay, last probability problem of the day. What is the probability of being dealt a hand with all diamonds? Now, we need to understand, what does probability mean?
like, what are the odds?
Well, we're going to talk about odds too. Actually, they're different to the mathematician.
Likelihood, like what is,
How do you calculate it? For example, if I said, flip a coin, what's the probability of getting heads?
50-50.
Those would be the odds. The
Oh,
probability of getting
50%.
heads would be 1/2.
1/2.
Why? Where did that fraction
Because
come
there's
from?
only 2 options. So one
Okay,
has-
so your denominator is the total options. I like that word options. And your numerator is what you want, right? I'll just say what you want. So if we want, we'll talk about this in a minute, if we want the
It'll
probability
be 13 over
of
52.
all diamonds, 5-card hand, all diamonds, our denominator is going to be this number,
52.
2598960, because total options would be the total possible hands. Do you agree with me? So your denominator is 52C5. We have the actual number right there. Now your numerator is what you want.
Be 13.
Jared, you doing okay today? We're doing the numerator, we're doing the problem that says, now I'm gonna yawn. How many 5-card hands have all diamonds?
But I didn't know which one you were doing.
Both of these are the same thing, okay? How many 5-card hands have all diamonds? Well, now you're not picking from 52 anymore.
It's 13.
If it's all diamonds, it would have to be 13C5, wouldn't it? Because if you have to have diamonds, there are 13 diamonds that you're picking from. So I'll put that down here. What is the number for 13C5? 1,287. So if we want the answer, we're going to type that in, right? And what do we come up with? What is the, that's going to be some weird decimal. What is the decimal you get when you divide that? Okay, watch it. It's not 4.95. At the end, there has to be scientific notation. -4. Two things I want to talk about. Mrs. Ford knew immediately it couldn't be 4.95 because this is a probability question. And what do we know about probability? It can never be bigger than 1. So I knew 4.95 wasn't the answer. Be very careful, look for scientific notation. This is 0.000495. If you are betting in Las Vegas, do not bet that you're going to be dealt all diamonds, because the probability of that happening is 0.05%. Not 5%, 0.05%. The likelihood of getting all diamonds or all of anything is not very good. Okay? We're gonna, we did this division.
I know, but once you have to have.
Well, it came out with scientific notation.
So it's -4.
Remember, you moved the decimal point.
Yeah, do you have to
Remember how you moved the decimal point?
Can you just look at such as
You're gonna leave it in scientific notation. I need you to understand though, that's a really tiny number. So the probability of this happening is very small. Now, we're going to spend more time with that, but I want to back up and continue the discussion we were having yesterday. We got a lot more probability to study, so do not panic. We're going to get it. You really, at this point, need to be able to do the M&M problems. So if you're still confused about those, you want to spend a little more time with those. But these card problems, don't worry. We're going to do a ton more.
How many points is that quiz out of?
Okay. All right, so here we go. Backing up. I want to expand 2x minus y to the 5th power. And I apologize if I've already done, oh, wait a minute, maybe I should just do one off the sheet. Oh, it is on the sheet, yeah, okay. So we're gonna do, on page 58, we're gonna do problem C. So on your note sheets, we're gonna do this problem. On page 58, problem C. All right. Now, we did talk about some of this. Who remembers how we start? Does anybody remember? Draw the triangle. So to refresh our memories, start with a 1 and a 1. Then we start and end with a 1 and add these two together to get the middle number. Then we start and end with a 1, add these two together to get the middle number. Start and end with a 1, add together, and then finally, same thing for the row that I want. Now, why do I know that's the row that I want? Because it's to the 5th power, so I use the 1, 2, 3, 4, 5th row. Now I'm going to write down that row of numbers, and I'm going to spread them out, so I have plenty of room to work. So step 1, write down the row of numbers that you need. Done. Step 2, next to each of those numbers, I'm going to put a 2x in parentheses and a negative y in parentheses. Next to each of these numbers, I'm going to put a 2x and a negative y in their separate parentheses. Now, before you start freaking out, where did the 2x and the negative y come from? The problem. The two pieces of the problem are 2x and negative y. Now, okay, so let's back up, make sure everybody's got it. Step 1, copy down the coefficients from the triangle. Step 2, whatever you have in the problem, write that down in 2 separate parentheses next to every single one of the numbers. Step 3, put on your exponents. We talked about this. If we're going to the 5th power, the 2x is going to start with an exponent of 5. And then what's going to happen to the x exponents? They're going to go down. So I'm just counting down, all the way down my list. I started with 5, I should end with 0. Now what about my y exponents? They go the other way. So 5, 4, 3, 2, 1. Did we talk about that within each term, I'm going to go ahead and separate these with plus signs so that you can see the individual terms. Within each term, did we talk about that the exponents add up to 5? Maybe not? Well, notice that. You see how within each term, the exponents add up to 5. Now, all you have to do is simplify. What's the matter, Katie? All we have to do is simplify, okay? So let's look at this first term. What is anything to the 0 power? 1. It's not 0, it's 1. Anything to the 0 power is 1. So we can actually ignore that. Be careful. What does this equal? 32x to the 5th. Mrs. Ford was really careful to tell you to put that in parentheses because you have to raise the whole shebang to the 5th power. So 2 to the 5th, 32. Okay? Next term. Now there's a lot going on. Pay attention. This is a 5. What are we going to have here? We're going to have 16x to the 4th and times a negative y. That's going to end up being negative 80x to the 4th y. Now how did I get 80? Well, I had the 5, and then I had the 2 to the 4th, which is 16. Now why is it negative? Because I have a negative to the 1st power, and that stays negative. What about here? What am I going to have? I'm going to have a 10. What's this? 8x cubed. It's now positive. It's going to be y squared, and it's positive because I squared it. So what will that term be? Plus
80x to the 3rd.
80x to the 3rd y squared. Very good. Now can you do the next one?
Yes.
You're going to have a 10.
Times 8x.
Not 8. It's going to be 4x squared.
4x.
And this is going to stay negative, isn't it? Now this is multiplication. So what am I going to have for this term? Negative 40x squared y cubed. Does everybody understand why it's negative? Because the y got cubed, and when you cube a negative, it stays negative. What's that term going to be? Positive or negative? Positive. 10x, y to the 4th. Bingo, perfect. negative y to the fifth on the end, because remember, anything to the zero is just one. So we disregard it, and we have negative y to the fifth. Oh boy, is right.
On the test, we only gonna have like negative
One, exactly one.
Okay, that's about the same.
Now, let's run through those steps again real quick. Step one, what's, well, yeah, if you don't already have it drawn, I asked you to put it on your note sheet, I think. But if you don't already have it there, you're gonna need to write down the triangle so that you can find the row of numbers that you want. You write them down. Then, what do?
Write them separately.
Next to each of those numbers, you put your two pieces of your problem in parentheses. We had a 2x and a negative y. Then what do? So you count down your first exponents this way, and your second exponents this way. Right? And then you just figure out each term, simplify. Okay? Thomas, can you get that? All right, you got homework for tomorrow. I hope you do it. I need my calculators back.